Okay, this lecture is titled Data Output Design. It is the final step in terms of your GIS application development, in terms of preparing the end product, whatever be it. It can be a soft copy, which is a digital end product, digital version of your map that will be viewed on tablet PCs or pocket PCs, or it can be in a hard copy in terms of a printed out map on piece of paper via printer or plotters. Now, you spend a lot of time collecting data and processing it, storing it, but you also have to spend a lot of time in preparing maps that are going to be used by your clients or the end users. Now, if these people do not use your the product, the end product, then obviously there will be no need for your service, and the job opportunities in terms of your deliverables will be looked upon as being not useful. So you don't want to be disregarding the important aspect regarding data output design. It's very, very important. We're going to look at, this is the table of content of this lecture. You're going to look at the graphic output. You're going to look at some of the issues regarding design in terms of the scale you choose and what sort of base map you're going to use and displaying your final map. And then we're going to look at map designs. I'm going to give you some examples of some good maps and some bad maps, and we're going to criticize them and make sure that you understand how important it is that your work is appreciated by the end users by way of they using the final results. At the end of this, I have a short YouTube video where you're going to see a 3D map, an animation of it, and it's fairly long. You could fast forward it, but if you want, you can have a good view of the type of 3D maps that we have when you start doing 3D GIS. In terms of the graphic output, just want to make this bold statement. Many GIS designed with poor map output capabilities. That is because GIS is a market upon which a lot of different professionals from different areas of specialization are getting involved in GIS, not knowing fully well of how it is done and the importance of every aspect, every step in the development of GIS application, and also that includes the final result being displayed in the form of maps need to be considered. What are the mediums upon which you're going to display your map? What is the best way of presenting the final result effectively such that your end users will make use of your results? Need to consider the text output, maybe more important than a map for analysis reporting. So if it is on a map that you want to be able to display text with the map as a background, then you need to know that up front and prepare the text in a way that it shows its importance. However, most of the GIS output is in the form of hard copy maps. All right, a lot of them are being printed off and being placed on walls or through conferences, or you have hard copy maps being displayed, and you want to know what's the best scale and what's the best color, things like that. And it is very subjective. Your GIS software is going to do whatever you tell it to do once you provide with the necessary information. It is we, the GIS people, who need to put everything into perspective and choose the appropriate mediums upon which we're going to display the final results. It can be in the form of graphic displays, pocket PCs, it can be on a cell phone. If that's the case, I need to know what are the restrictions in terms of how effective I'm going to display a map effectively on a small monitor like a cell phone. You also need the design of the graphic output is critical to effective use of the GIS analysis. So up front, you need to know what is the medium through which the final output or outputs is going to be used to display the results. Graphic output from GIS usually poorly designed. Yes, because as I said before, the general user in GIS is not fully knowledgeable in the different areas and the different steps that are required in the application development. Colors are used randomly without appropriate or conventional scaling are used in cartography. There are, in GIS you can choose whatever symbol you want, whatever color you want, but in cartography there are a certain methodology through which the cartographer will prepare the maps. The greater the capability of a screen display introduces more challenges than the standard paper. If I am preparing a map that's going to be viewed by the end users via the computer, it means that the users can zoom in and get more detailed information. And I do not want, or GIS people do not want, to be displaying inaccurate or errors in their data because it will show up bad on their side. If I have to prepare a map that is a hard copy map, that also needs to be just as accurate. For GIS, the graphic output should show features approximately symbolized or labeled. I want to be able to show the features that are on my data layers at a scale such that it is easily visible, especially the features that are important to the intended application, and also properly labeled. Not with any fancy fonts, but it should be legible. Labels should not be overlapping each other, so it should be legible in the form of there is no confusion in terms of where does that label point towards. Referring to, sorry. Objects also computed by the GIS. The results must show if I have created buffers, if I have done some generated some 3D models. If I've done some distance analysis, things like that, it should be shown explicitly in your final result. And very important, relationship between features. Remember, the whole intent of using GIS is to show the spatial relationship between features. And how do we do this? Is by choosing appropriate symbols and also colors help in displaying that spatial relationship effectively to the end users. Cartographic traditions are fundamentally important in GIS. So yes, at the beginning of GIS development, the GIS developer had to put on different caps of caps of data collection and caps of a person who's doing the database development. Now he's been called upon to put on the cap of a cartographer because he spent a lot of time. You need to also spend a lot of time in understand how the cartographer prepare maps and do the same with his results. Graphical excellence, which is to create the best output at the minimum requirements of the hardware. Remember, computers do not make good or bad maps. It is the cartographer, it is all of us who are preparing the maps. We need to understand that we need to choose appropriate symbols and also understand the type of information we're going to display, the importance of these information, and prepare effective maps that the end users will make use of. It has been very difficult to display the results of some of the GIS analysis, especially in a 2D environment. When we want to display a 3D result on a 2D environment, that is a big challenge. How do we show 3D? There are different ways. We do that by using the appropriate symbology, using hatch patterns, and looking at displaying the data such that you can actually see third dimension on a 2D environment. There's also a challenge in terms of identifying how do we show interaction data, migration data, how much people are moving towards a certain development area. How can we show real-time data? How can we show the usage of the roads early in the morning as opposed to during high traffic time and or during low traffic hours? How do we show global data? How can we show the entire Earth? And the GIS software that we are using nowadays, they are more going towards those areas in terms of being able to display your data in a global context, being able to display your 3D data, being able to show some interaction with your data, migration patterns, etc. Scale is an important consideration, of course. When we are looking at displaying our end results, we need to know what is the appropriate scale at which we're going to display these results. Now, the scale, it is such that we want to be able to display the features that is consistent with the intended application. It is inappropriate to digitize from 1 into 1 million map scale and display at a level of detail, more detail at 1 into 24,000, because if we did capture this level of the detail, we can't get anything better than 1 into 1 million. So displaying it at a 1 in 24,000 is really a very inaccurate method of displaying the final result. Also, it is inappropriate to digitize at a 1 into 24,000 and display at a 1 into 1 million without adequately generalizing. So the reverse of that is actually it's not something that I would recommend, because if I'm going to collect at a very large scale, which is 1 into 24,000 here, and display my end result, my results at a 1 into 1 million, then it defeats the whole purpose of collecting at that level of detail. Now, scale is another consideration when we start talking about the if I'm going to display this on a monitor or in a digital environment, then the scale becomes more and more apparent, an important consideration. Now, in order to display a final result, you're going to have not only the important data set that is used in the intended application, but also you need to put in some additional base map information. For example, you might want to put in road network just so that the end users can have a sense of orientation. They might know certain roads. So you want to be able to include some base map information for the main intent of establishing some sort of an orientation with the end users who are familiar with the area. Output of computer information alone is rarely useful, and there is need for base map features. So you might want to add, I'm not saying go ahead and add everything. Be selectable, be wise in selecting features that you know is going to be helpful for making the end users a bit more comfortable with using your end result. It's particularly important in raster structures where your data is in raster format. The base map information will normally be a vector or at a higher resolution than the raster. So you want to be able to mix and match a bit about the mix and match the raster data with some vector data. General graphic map design, often desirable to create an acceptable finished map. It's for the main reason that you want the users to use your product. High cost of providing cosmetic output functions in GIS. Example, if you're going to put additional border lines, neat lines, symbols, inset maps, and other, other fancy additions to your map, that's going to be costly. I'm not saying that a border line or neat line is not important. Yes, there are some basic requirements that all maps should have. But at the same time, you don't want to be putting unnecessary information such that it's going to make your map a cluttered map. Time taken to plot these features may be high, and particularly for pen plotters if you're using some pen plotters. But nowadays we hardly ever see any pen plotters being used unless you are into some sort of a network analysis application. So you need to decide what are the critical aspects of what all maps should have. This is an example of a map. It's a very nice map. It has a neat line of the area of interest. Where is this area of interest? This is the country, and they have a box indicating my study area. This is a blown up version. And what's inside here, they're going to have an inset map. Where is this in relation to the entire country? North arrow, this data source, a scale bar, and what you might want to add to this map is a legend. But all in all, it's a good map. Production of map requires the selection of the features that you want to display in the real world to include in your final map. You also want to put in any classification of the data or categories that you have derived in your analysis stage to include that in your final map. You want to put in some simplification of some complex lines. Do not put in all of the bay areas, like if I'm looking at an island and you want to put in all of the detailed beaches and coastlines. You will want to simplify that. Exaggeration of included features that are too small to show at the scale of the map. So try, if a particular feature is important to show, you might have to exaggerate that a bit, but know that everything you put on the map is going to be looked upon as being the map that you have generated. So you want to be able to justify whatever you put on that map, how accurate it is, etc. Symbolization of different classes of the selected features. You want to put proper symbols to represent the different classifications that you have set up in your final map. Questions to be addressed in making a map. What is the goal of this map? Who is the intended user of this map? Where and how this map will be used? What data is available for the composition of the map? And also I want to extend what additional data you might want to add, what additional base map information you might want to add to your map layout. What resources are available in terms of time, the equipment, etc. All these are important questions that GIS application developers who's preparing the results need to know and need to get answers before they start preparing these maps. Is appearance really important in a map to support decision making? Yeah, it does. Especially if the people who are going to use the map to make a decision, if they can't understand what is being displayed, obviously they're not going to use your map. So appearance does matter. Consideration is needed if the GIS output are to be used directly in the form of a soft copy, or if it's going to be placed on walls or map libraries. In that way, you can effectively prepare maps that are intended for its that are used for its intended use. Consideration is needed to decide if GIS products should be simple, schematic, in order to avoid high cost of manual cartographic quality. So, if you're going to, you need to know upfront what type of map you're going to prepare. Is it going to be a detailed map? Is it going to be a very cost-effective map in terms of it's going to be costly for me to print this map, or is it going to be made a simple map? All right, where is this map going to be used? Is it as a hard copy or soft copy? So the ultimate goal is making sure that your end users make use of their final result via maps. Okay, we're just going to go through a sample of maps and just look at some of the good manner in which it is presented. Is it a good map or a bad map? Comments about this map. The good thing about this map, it shows the entire country, and it also shows a 3D perspective. You can see the ruggedness in this area. You could actually see some mountainous areas as opposed to the more flat areas. So in terms of 3D perspective, it can show a bit of a 3D perspective. What's bad about it? The road network is great. The cities, the symbology is okay, but what happens here, if you look at the text, it's actually overlapping. And this is reason for concern because we cannot read the text. So it's really not important to put in all of the text. This is another map, and this map of Iraq that I got online. It shows these surrounding countries. We have a nice legend, the name of the map, but I want to know what type of information is not just the country, but also what information is displayed. So I want to have a proper name of the map. The scale bars are shown. They have used some hatch patterns to represent the third dimension. It's not very effectively done, but you can still see that here it's relatively flat compared to this area. Now the labeling is a bit, when it becomes in cluttered area here, it's not clearly defined. So all in all, as I say, it's an average map. Where is the north arrow for this map? It's non-existent, so you need to put that in also. Another map, much better map. You have the same legend and scale bar, better title for the map. Symbology is excellent. The text is great, and the study area is in an inset map here with respect to Iraq and Iran. Much better map. The only thing that this map is missing is probably a north arrow. This map is lacking. It shows a bit of a 3D perspective, third dimension, but here being rugged, and the other areas relative to the rugged areas. The naming of these cities, it's very confusing in some instances. For example, we have these cities here, but which one of these names are for which city? So they might have preferred to use a smaller font, such that it's consistent and it'll point to where these cities are, the name of these cities are located. Now, what is missing in this map is legend, north arrow, title. So this map is not a good map. In this map we have, again, Iraq, Iran. It's a better 3D perspective on a 2D environment. The text color, the green, it does not show up too clearly in the map, so I would have preferred a different color that stands out. But what's missing here, just a north arrow. All in all, it's a good map. This map is a bad map. Why? Because I do not know where this map is in relation to the Earth's surface. So what's missing is an inset map, a north arrow, scale bar, and legend. So this map is a poor map. This is a map that they would have online, and what I wanted to show you here, this map have symbology that is indicative of the type of vegetation or farming product that they are actually farming. So we have barley, cotton, dates, rice, vegetables and wheat. So specific symbology that's indicative or mimicking the actual vegetation that they're using and that they're planting. It's a good map in terms of the symbology, but I don't know where this map is located in relation to the Earth's surface. Also, there's some classification of land use, very useful information. So I would say, because I don't know exactly where this is in relation to the Earth, it requires an inset map. I would say this is an average map. This is a map showing physical features of what they need to have proper name in here. The north arrow is missing. Different perspective. A legend would be helpful. A scale bar would be helpful. I would say this is it's missing a lot of information. So I would say it's a poor map. This is by far a very bad map. Why? Because we have the bright color that draws my attention of the water areas, but if I see this name and this name, I'm thinking that this is Greece, or this is Turkey, this is Athens out here. And plus the name of the cities are very the texts are cluttered. Poor map. There is no legend, no north arrow, no scale bar. Very, very poor map. This is a map that they used to map radiation hotspots resulting from Chernobyl nuclear power plant accident in 1986. It shows the zone area, permanent control zone, periodic control zone areas where there were some reports of the radioactive material get into the atmosphere in the Chernobyl nuclear power plant. It has a good legend, scale bar. What's missing is a north arrow, and I will put in also an inset map. So this map, I would say, is an average map. This is a map of nuclear power plants in the Soviet area. And what I wanted to show you here is that this is a set of point features indicating where the power plants are located. But each one of these power plants has specific additional information, the operation of them, and whether or not they are for particular characteristics in terms of this operation. It will have the appropriate symbology. Good map. North arrow is missing. Scale bar is there. I would say this is a good map. This is a more detailed map of the Chernobyl accident in '86, where they had a radiation cloud. And if you look here in this map, it's a different projection system where the main area to minimize the distortion, they wanted to show the Chernobyl area here accurately. Everything else is displayed with higher distortion, more distortion as you move away from this area. But that is the radioactive cloud in April 27th, and by May the 6th, it was anticipated that it will be all over the Asia and certain parts of Iceland area. It requires a better legend, a scale bar, and north arrow would be helpful. I would say this map is lacking certain important characteristics. A good map or bad map? This is, I would say, a good map in terms of what the legend is showing, a good name. What's missing is a north arrow. An inset map is should have been, because I don't know where this is located. It looks like Texas area. Scale bar will be helpful. All right. So average map, I would say. A better map with educational attainment, the 1990 census tracts. What is a good legend? I need a north arrow, an inset map should be included. If you look at each one of these bar charts with respect to a specific point, and more information is displayed from its attribute table. Scale bar would be helpful, and I would say this is an average map. A good map in terms of same sample area but different data set is being shown, displayed, different results. This is total households, average net worth, percentage with some college, and average household income. And this is looking at market analysis, demographics in certain areas in San Francisco in 2003. Very good map, very good. North arrow, scale bar, excellent map. This is in Holland, the Netherlands. I would have preferred to see a north arrow and an inset map with respect to where is Holland with respect to Europe. A scale bar would be helpful, but they're showing here for each one of these counties there are a number of bar charts, money laundering density information. Okay, so average map lacking some information. Okay, in this last map, you will be looking at a 3D animation map of a sample area, looking at the watershed of that particular area, and the watershed will be shown up as a red line overlaid on the topography of the terrain. In order to start this video, I would strongly urge you to run the PowerPoint, and then it's a YouTube video. Run the PowerPoint and press play at the bottom of the bar, and run. It's the entire length of the video is 3 minutes 49 seconds. So you might want to, run it through in terms of the important aspects of seeing how the 3D buildings are extruded, and also seeing how the other features are actually overlaid or draped over the landform. It's a very useful video just to give you an idea of the type of 3D animation that GIS is heading towards.